Hey everyone, welcome to Software Wolf. I'm Jesse, and today we're starting a series of challenges where I'll be tackling different programming tasks to become an expert programmer. Today, I'll be implementing some core data structures in C. This should be fun, especially since C and I have a love-hate relationship. So let's dive in and see what happens. In this video, I'll be working on arrays, linked lists, tags. I'll be implementing basic operations like get value at a specific index, search for a value, inserts, and deletes. I am aware that there are a lot more advanced data structures, but most of them are based on the ones we are going to implement in this video. So let's get started. So we kick things off by creating a Git repository, because who doesn't love version control, right? Then we added a fancy README file to make our project look professional and not like a random mess. Finally, I threw in some skeleton methods for our data structures, because every good project needs a spooky foundation. First up, arrays. Think of arrays as the simplest form of data storage in C. Imagine a row of lockers, each with a number from 0 to n. You can store a value in each locker and you always know exactly where to find it, because you can use the locker number or the index. Adding a value is like putting a book in a specific locker. You just open the locker by its number and place the book inside. Getting a value is like opening a specific locker to see what's inside. You just use the locker number to access it. Searching for a value is like checking each locker one by one until you find the book you're looking for. It can take some time if you have a lot of lockers. Deleting a value is like removing a book from a locker. You open the locker and take the book out, but the locker stays there, ready to be used again. So we first started off with creating a struct of type array, and we give it int size and a pointer to the start. Then after, we fill up our array with 10 different numbers. For this, we will make use of a for loop. For the implementation of the set value at a specific index, we will start from the array.start. This is the memory address of our array, and then we will increment it by our index multiplied by the size of the int. This way, we will get the correct pointer, and with this pointer, we can change the value. We also implemented a print function, so we can display all of our values from the array. From this moment, we've encountered some bugs. So first off, it didn't display all the values, so there was something wrong. And the second bug was really weird. It displayed all of the values correctly, except the value at index 7. Weird enough, changing the amount of numbers from the array from 10 to 100 made it work correctly. And at last, we implemented the search method. So we used the for loop to look over each value, and if this value at the specific index is the same as the value that we're looking for, we just return the index. Okay, getting the value at a specific index done. Searching for a value, a bit like finding Waldo. Inserting and deleting values, well, not for the array. Next, linked lists. Imagine a conga line where each dancer knows only the person in front of them. Each dancer holds hands with the next one, creating a chain. If you need to add or remove a dancer, you have to make sure the chain stays intact. Adding a value is like inserting a new dancer into the conga line. You have to get the new dancer to hold hands with the one in front and behind them, without breaking the chain. Getting a value means starting at the beginning of the conga line and counting dancers until you reach the one you want. It's like saying 1, 2, 3 until you find the right dancer. Searching for a value is like asking each dancer one by one if they are holding a specific number or item until you find the one you're looking for. Deleting a value is like removing a dancer from the conga line. You have to make sure the dancers on either side of them hold hands with each other so the line stays intact.
We start off by making a struct of node, which contains one value and one pointer to the next node. Now we can see that I made a mistake. I had an int pointer, and this should be node pointer to the next node, but we will fix it later. Then we initialize our linked list by providing a value and setting the pointer to null. Now we want to fill up our linked list, by implementing the insert function. So the insert function, we will make a new node, we will allocate it a memory, and then we will set the value of the new node to the value that we want to have, and we set the value of the next node, so the pointer, to the parent. Now, at the end, we switch the parent, so this parent becomes the new node. So for the delete method, we first of all create a new node named current. This is a pointer to the parent. We also keep track of the previous node, which we set in the beginning to null. So while the current one is null and the current.value is not the same as the value we want to delete, then we set previous to the current one. The current one will be the next one. So if current is equals to null, we return, so we didn't find the value. If previous is equals to null, then we found the value. So then we want parent to be equals to current.next, or else previous.next will be current.next. After this, we free up our memory. Getting a value at a specific index will be almost the same as the print function, because we will loop over the linked list by looping over every node. We will keep track of the index, and when the index is the same as the index we want to get the value at, then we just return node.value. Last but not least, we implement the search function, which will almost be the same as the previous one, except we don't check on the index, but we check on the value. And we return the index of the specific value found.
Stacks are like a stack of plates. You can only take from the top or add on the top. It's a last in, first out structure. Pushing onto the stack is like adding a new plate to the top of the stack. You just place it on top of the others. Stacks don't typically allow random access by index. You can only interact with the top plate. Searching in a stack usually involves checking each plate from top to bottom, until you find what you're looking for. Popping from the stack is like taking the top plate off the stack. You remove the top plate, revealing the one beneath it.
For the stack, we start with making a struct named stack, which contains an array of 100 integers and a top. Then we initialize it by creating a struct stack named stack, and we set the top to -1. Now we want to fill up our stack. We do this by creating a for loop of 100, and we implement the push method. For the push method, we want to check first that our stack is full or not. So we look on the top, and if it's the same as maximum size -1, then we return. Else, we just add the value to the top of our stack. The print function is also pretty simple. We just look at the top of our stack and we print the value. After we printed it, we just go down and check it again until the stack is empty. Then we implement the pop function. This is almost the same one as the push one, except we delete the value, so we have to check if the stack is empty first, because we don't want to have a stack overflow. So we check if stack.top, and after this we remove the top value.
Wow, what a journey. Today we tackled arrays, linked lists, stacks, queues, trees, and graphs. There were laughs, there were tears, and we all learned something new. If you enjoyed this, hit that like button, subscribe for more coding challenges, and leave a comment with your thoughts or suggestions. For my next challenge. Thanks for watching, and see you next time on the Software Wolf.